Alright, so here we go. I drew this problem up there in class. We got to find the area between square root of x, which is this, y equals x minus 2, which is that. I didn't draw the bottom because I'm also going to go between the x-axis, so this region in here. We can't just do the integral from 0 to, this is 4. We can't just go from 0 to 4 of square root of x minus 2 because that would give us this, but it would also include everything down here that's underneath this one, you know, between these two. So like Rumble said, I don't know if you guys heard it, if I break this up, and so I go from 0 to 2 underneath the square root of x, that'll give me this region, and then I can go from 2 to 4 between these two, and that'll give me that region. So my integral will be from 0 to 2 of the square root of x dx. I don't need to subtract anything, right? Well, it's basically like subtracting y equals 0, right? Because every time we integrate, that was back in the good old days, it was just between the curve and the x-axis. And I'll add to that the area of this one, which will be from 2 to 4 of, the top one is the square root of x minus 2. But I'll put that in parentheses. Don't want to just put minus x minus 2. I'm not holding very still here. Eating too much cake today. Alright, so we got that. Now we just got to do it. And for the sake of being brief on this video, I don't think I'm going to do it. I could do it out by hand, could do my calculator. I think this, if I were giving this to you, this would definitely be a non-calculator problem. You need to do both these by hand. The answer is 10/3 if you want to try it. That's just how you set it up, just a different way of doing it. Alright, just do that integral, take your answer, add it to the answer for that one. Golden. Okay. There's yet another way to do this same integral, and we won't have to break it up. Or not, I don't want to say same integral, but same area. So if I draw it, it's very hard to only draw with one hand. I'm going to set this down for just a second. Okay, so I got that. Again, same thing. I know it looks a little different, a little uglier. And I want to find this area between these two. I can integrate with respect to y. And the way I do that is, I think of, instead of going, you know, between here, kind of think of it as sideways. Okay. I don't know how you would think that. I just kind of picture it, instead of moving from left to right, like if you were doing a Riemann sum and you're putting in all the boxes, all right? Because that's what an integral is. It's basically it's a Riemann sum with really skinny boxes. And I'd put all my boxes in this way. Well, now I'm going to put all my boxes in this way. So I'm just going to have rectangles between these two. That's integrating with respect to y. So I'm going this way. And all I've got to do then is, this point that was given above, it's 4, 2. All I've got to do then to integrate with respect to y is, first I need to solve each equation and get it as a function of x. So right now I have y equals on both. I need it to say x equals. So on this one, just add 2 to both sides, so x equals y plus 2. And on this one, I would square both sides, so x equals y squared. And so now I'm going to integrate with respect to y, so I'm going to go from 0 to 2 on the y-axis. Man, the paper keeps moving. It's not working. Alright, go from 0 to 2 on the y-axis. And then I need to put, when you subtract, you got to make sure the one with the bigger values goes first. Like up here, these are bigger values on top. So I do that one minus this one. Well, if you're thinking in terms of y, and I'm integrating going this way, the bigger ones are right here. So I'm going to have this minus this. Because my area, if I integrate from 0 to 2 on y, my area is, it's going to be the area under this curve minus the area under this one. You got to think sideways. So I'm going to put this, this one right here, the line, the y plus 2 first, minus y squared dy. And once again, for the sake of time, I could do that by hand, right? I'll just do it real quick. 1/2 y squared plus 2y minus 1/3 y to the third from 0 to 2. And if you plug it in, you'll get the same answer of 10/3. So that's integrating with respect to y. And that might help on your homework from last night on problem 3. They gave it to you as x equals. Well, that one you could switch it to y equals third root of x and y equals square root of x and do it with respect to x. Or now you could switch it and do it with respect to y. Same with number 4, which you couldn't do last night because you didn't know how to do it with respect to y. Well, now you can do that one and do it with respect to y. So that's kind of why I didn't check homework today, because I was like, well, knowing this now, you can go back and finish it from last night, and I'll check it tomorrow. But of course, there will also be some more. There's one other way we could have done this integral here, using a little geometry. I could have just done the integral. Here's this is square root of x, right, from 0 to 4. This is a completely different way, so ignore all this. Ignore all this. I just want to redraw it. So I could have gone from 0 to 4 and done the square root of x dx. That would give me all of this area, right? Well, then I've now formed a right triangle right here on this one, with a base of 2 and a height of 2. So that's the area of that triangle, 1/2 base times height is 4 divided by, so the area of that triangle is 2. So I can just integrate from 0 to 4 of the square root of x and subtract 2 from my answer. And if you do that, so this would be, let's see, x to the 1/2, so 2/3 x to the 3/2 from 0 to 4. Yeah, I don't feel like doing that, but if you did, you would get, let's see, I'm guessing 16/3, and then you would subtract 2, and you would end up with the same answer. So 3 different ways of doing the same thing. And I don't care which way you do. It's all up to you. You could break it apart and integrate with respect to x like that. You could integrate with respect to y, or you could break it in, if that happens where you know the area of that little shape and you can break it up that way and do it that way, that's cool too. And so that's really it. I told you I'd try to keep this video short. That's all. So for tonight, where did I write down? I lost my homework. There it is. Right there. Finished last night's, including the problems you couldn't do. So last night's was 2 through 5, 7 and 8. Now we're going to do 9, 10, 13, 14, 17, 27, 28. Please pay close attention to calculator and non-calculator. 9 and 10 are not calculators. 13 and 14 are. 17 is a no calculator. And then 27, 28 is calculator. And when I say no calculator, that's not even to graph. Just put it away and try to do it completely by hand. 9 and 10 are already graphed for you. So the real challenge, the only challenging one would be like 17, where you don't get to look at the graph. And keep in mind on 17, first thing you'll need to do is find your points of intersection so that you know where to integrate between. And remember, when you find your points of intersection, that's the region you need to check to see which one's on top, so you know which one to minus first and stuff, right? You know what I'm saying? And that is all.